who's monitoring the chat right now in the main room? David, can you do that?
Hey guys,
Okay.
can you hear me?
Okay, so I'd like to welcome you all to this workshop. I'm so glad you're all able to be here. There are now 73 participants, which shows the urgent need that we're all feeling to be able to connect to our fellow musicians. David Tarlow and I are one half of Hudson Valley Sally. We're a quartet, and we, of course, have felt the same need. So we're aware of the limitations of Zoom and other platforms like that. And that led us to explore the different platforms that are supposed to allow for better and closer online experience.
We've actively tried all three of these platforms. We, of course, especially want to welcome and thank our panelists, Chris Chafe and Aaron Wyatt from Jack Trip, Alexander Cahot from Soundjack, and Jesse Chappell from Sonibus. We are honored that you all agreed to participate in this workshop and share your projects and experience.
Yes, and we also want to thank and double thank Cynthia Payne, who has so much experience with online music and these platforms, and we hope we hope that you have had success in downloading and installing these programs with the instructions that we provided you, or with the extra help that we've provided afterwards. Mostly Cynthia has provided afterwards. So for those who still need help, Cynthia will be available to help you. She's volunteered to do so. You can send her a private message in the chat, and she will take you to the emergency help breakout room for assistance.
So a little history.
Where's
a
that
little
room,
history. Oh, sorry.
Say again?
Where is that room?
Oh, yes. There are, if you look at, do you have the breakout room icon
yes.
at the bottom of the screen?
Oh, yeah.
There is one breakout room called emergency help.
Okay.
And that's where you can go with anybody who needs extra help.
Lori always had a great imagination.
I didn't wear my EMT hat. I guess that makes me an essential worker.
There you go.
You are definitely essential,
Right.
Cynthia.
We got your shot already. A little history. So we first connected with Chris Chafe of Stanford University and the developer of Jack Trip before last summer. When I heard about it, and then we followed one of his online classes, and he graciously allowed us to sit in towards the end of a class he was giving at that time.
And we have stayed connected through weekly Monday meetings of an online group called IETF, or Internet Ensemble Tech Force, at CCRMA, which is Center for Computer Research in Music and Acoustics at Stanford University.
Last fall, during one of these IETF meetings, sort of curiously enough, I heard about Soundjack, and we tried it out. Through our attempts there, we connected with a wonderful musician from Germany, Bernd Keul, who has done a lot of work with Alex Cahot, and also introduced us to some other musicians through that platform with whom we've explored all three platforms.
Finally, Bernd also was the one to tell us about Sonibus, which is the newest of these platforms. We've been trying that out for the past 2 months as well, including a session with Jesse, who personally helped us through with some of its features.
Before we turn the show over to these wonderful engineers and musicians, we want to point out how accessible they have been to questions even before we really knew them, and of course how grateful they agreed enthusiastically to join this panel. Through all of our interactions with them, including this forum, it has become clear that although they are providing different solutions to the same problem, they are doing so as a way to provide a service rather than as a competition.
So I'm sure you're all wondering which platform we think is best. And aside from it being a bad idea with everybody, with all of the creators here, we do want to emphasize that these three developers are actually communicating, learning from, and playing off each other. All have some distinct features, and it is not a one-size-fits-all situation.
Laura, you're echoing. Something just changed.
Yeah, I know. I'm not sure what it is.
Yeah. Oh well.
Someone has their
Someone
mic,
right. Someone is not
active
muted.
and
Someone is not muted.
and they don't have headphones on.
Yeah. Yeah.
Yeah,
There you go. So here's the plan. The three panelists have agreed that Alexandre Caro will start us off with a presentation of some of the key technical ideas behind all these platforms, and then, of course, tell us more about SoundJack. This will be followed by Chris Chafin and Aaron Wyatt, and then Jesse Chappell for Sonibus. We expect this section of the workshop to last about 45 minutes. Then we will reassemble in 3 breakout rooms where hopefully you will succeed in trying out one of these programs. Note that all 3 rooms will be recorded, so soon you will be able to watch the videos from the other 2 sessions via PMN.
You can present your questions in the chat. We will try to get to as many as possible, but we definitely want to leave at least 45 minutes for the breakout rooms. These should be more about overall topic as opposed to techniques of the particular programs, as that will be covered more in the breakout rooms. So we just want to thank all of our people that have offered to help us with the chats. That would be Erland and Tony and David Heitler Clevens and Hallie Hammer. We really appreciate all of you for stepping up and helping us with the chats and the recordings.
So without further ado, let's start. Alex, you are on.
Here we go. Can you hear me at all?
Yes.
You can. That's good. Okay, so I'm sharing my screen. 1 second. Can you see it?
Yep.
Good stuff. So hello, everybody. My name is Alex Caro. I'm a professor in media computer science in Germany. I mentioned that because this talk will mainly be about the essential basics, fundamentals of network music performances. But besides this, I am the developer of SoundJack and therefore have been investigating network music performance for 20 years. And it was important for me to outline the essential basics because most of the current platforms nowadays, I don't want to say they do the same, but they do almost the same. And it's quite important for me to outline these general principles in order to make you in the audience understand what the whole topic is all about. So this is more about the general principles. Sometimes I will get back regarding the implementation in SoundJack. Let's see, but the focus on SoundJack will be within the breakout session. That's the whole idea of my talk today. All right. Okay. So first of all, we have to talk about the audio transmission path. So what is actually happening when we transmit audio from one internet endpoint to another or to multiples? And there are several stages which we all have to think about in how far they introduce latency or not. And if they introduce latency, how significant is that amount of latency generated by that specific stage? And now we will quickly go through all these stages in order to get an idea of them. So first of all, there's the sound generator itself. So the vibrating medium which transmits the audio data through the air with an average speed of 330 meters per second. And so I explicitly marked that stage in dark gray because this is significant already, because that means 3 milliseconds per meter. And in turn, because the whole sound will be captured by a microphone or some other capture device, basically, it is really recommended to stay as close to the mic as possible because, as I said, it's 3 milliseconds per meter. Imagine you are 10 meters away, which is of course not very useful regarding the actual sound, but that would generate 30 milliseconds already. So take care about this on the capture side, but as well on the playback side regarding the distance of the speakers. ideally wear headphones. That's the message. Then, of course, we have the connector itself. So this is all related to the speed of light. So this is virtually no delay we have on the cable itself regarding the transmission of analog signals. But then we enter the digital path. And as you can see here, we have much more gray in that, but of course also on the internet path on the right, because the digital technology implies the introduction of additional latencies due to the capture process and the buffering and all that stuff. But the first is the so-called anti-aliasing filter, which gets rid of frequencies beyond the 20 kilohertz upper threshold, and this already introduces latency. And some sound cards have more latencies generated by the anti-aliasing filter, some others less. So you basically have to figure out what is the latency. So the input and output latency generated by your sound card, independent of the other stages, of the following stages I will introduce now. This is so the very first part, and it differs from sound card to sound card, and even some very high quality sound cards have larger latencies than some cheap ones. So this is strange these days that some vendors really emphasize latency rather than quality, and it's actually a draw. It's a decision. It's up to the vendor and basically up to you which sound card you would prefer. Then there's the Sigma Delta converter itself, which does the conversion from analog to digital. Once we have done the digital conversion, we have what we want. We have the audio samples. And it would be great if we could transmit every single audio sample from the sound card to the user space of the computer. However, this is not possible because the system itself is not fast enough. So what you basically do is you buffer a certain amount of samples, and then you transfer this block of samples blockwise to the user space. And here it's a matter of CPU performance, how low you can go with that specific block. It's a good value to have 64 samples per block. Some systems can even do 32, but 64 most systems is the lowest possible. And this already introduces 1.3 milliseconds of delay at 48 kilohertz sample rate. Some others can't even do 64, and then we end up with 100 to 28, and that results in already 2.7 milliseconds of latency just for the input side because of this double buffer system. That's the input principle of the sound card. It's a double buffer, and there we need these blocks, and these blocks takes time being transmitted from the sound card to the user space. Once we have that block, we must have an awareness of the following transmission path, if it is possible to send that block uncompressed over the line. If not, we need to compress basically. So we have to apply audio compression, make it smaller in order to fit the actual bandwidth. This is nowadays not really a problem. Most internet upload speeds are sufficient in order to transmit uncompressed linear audio, but there are other arguments for still applying encoding, but this is leading to some more complex issues which I don't want to outline any further. Then there is the transmission medium itself. So that is basically the sum of routers and switches on the internet. And with every router and every switch, there is also a tiny latency because the switch and the router, it requires a certain amount of time to actually forward that packet. That basically means the more routers and switches we have, the more latency we have. However, with respect to the exploding bandwidth we already had, this is already not neglectable, but has become very, very low. But I still have marked that stage in dark gray because it still matters. Then we enter the internet path, and here we add the UDP, the IP, and the Ethernet header on top of the actual audio payload. And that altogether is our routable internet packet. This is what we can send across the internet. And then comes the actual problem, because the transmission path never happens in a manner as the crow flies. What you see on top, it looks like a metro plan or some subway plan. And it is like that because this is the backbone of the internet. It's a little older drawing from the so-called Géant backbone in Europe. So this is where the major traffic goes through regarding European traffic. And you can see that in some cases you don't have direct path. For example, if you are here in the north of Germany and you want to reach out to Copenhagen in Denmark, which is, I hope you can see my mouse pointer, that would be that tiny distance corresponding to about 400 kilometers. However, there is no direct connection between the north of Germany and Denmark. That basically means you have to go south all the way to Frankfurt, which is here. Then you have to go twice the whole path up to Sweden, to Stockholm, and then you go south again to Denmark, and that basically ends up with a route which is 5 times larger than the direct path from North Germany to Denmark. So we rely on this backbone, and that's a problem because, and what you see in the lower picture, besides the latencies introduced by routers and switches themselves, we also deal with the speed of light, or actually 70% of the speed of light. That is the speed we can reach in a fiber. And if we had a direct path as the crow flies across Europe, you can see that even with this highest possible speed, we could only cover a distance of approximately, let's say, 3,000 kilometers, more or less, with 28 milliseconds. And this is the problem, because we somehow have to achieve lowest latencies in any case, because this is not necessarily an international scenario we can apply this way. Okay, so the speed of light and the problem with the existing lines of the backbones and the routing itself, this in combination at the end determines a significant part of the overall latency. Once the packet has arrived at the receiver, the packages have to be extracted. Then there's a so-called jitter buffer. If you have a connection which is very stable, you don't have to adjust this jitter buffer very high. But if you don't have that, if some of them arrive earlier, others later, you have to make sure that they can still be played back in order to not get a glitch, in order to not get a dropout. This is why you have to adjust the audio buffer accordingly, but the higher the buffer, the higher the latency. And the latency for every single packet corresponds to what I described above, to the amount of samples within one packet. Then it has to be decoded in case it was encoded on the sender side. And then at the output, you again have a double buffer, as I explained above. And here we have again the latency introduced by the sound card. Then there's the reconstruction process. Then we have the analog amplifier. Here we are fine. Here in analog signal transmission, we don't have to care about latencies. As you can see, there's the connector, there's the loudspeaker. Please, as close as possible to your ears. Then the signal is routed to your ear, so to speak, and it enters your brain and makes you actually hear what the other person has sent. So this is quite complex, and it is the challenge to take all these stages into account and make every stage generate the lowest possible latency. That is the whole challenge in network music performance. Cognitive aspects. In voice over IP, it's not that dramatic because a classical conversation can take 400 milliseconds of latency. It is maybe not that convenient, but you can still talk, as we can do with Zoom now. These tools, they all deal with this classical telecommunication standards, and almost half a second is still something considered acceptable. But the quality also is reduced because you don't necessarily deal with the whole range audio. Video conferencing, same thing. However, video might possibly be synced and audio suffers. In distributed music, latency should be 25 milliseconds or less, depending on the actual interaction modus, which I'm going to talk about in a bit. The quality requirements should be 20 kilohertz, and video does not necessarily have to be synchronous with the audio. So this is our conventional use case, having, I'm constantly picking a rhythm section like bass and drums, because here we have the rhythmical fundament of a musical ensemble. And these two suffer mostly under aspects of latency. And wow, now we move it to the digital domain by having one room anywhere and having another room anywhere and connecting them via the internet. And we made some experiments. So we didn't use the internet like almost 20 years ago. We took a delay processor in the studio, and then we figured out, okay, what is the latency rhythm sections can deal with. And not digging too much into this graph, but here we can already see that there is really no clear answer. What is the precise latencies musicians can live with? So we ended up with something we called EDAL, the Ensemble Delay Acceptance Limit, which is an individual value. This is very important. It falls with increasing performance speed, and it also falls with increasing note resolution. Basically said, the faster we play and the higher the note resolution we are playing, the more issues we will have with latencies. And the slower we play and the lower the note resolution, the more latency we can accept for a music performance. Nevertheless, 25 milliseconds works pretty well as a rough guide value for most performances. But definitely not for all. Some of them suffer with 15. Some others can live with 60. So it's really not really determinable to a precise value. And now, that being said, let me give you an example. Or first of all, how much time do I have altogether? I think we started 10 past, right?
Yeah, we started about 10 past.
Okay, so yeah, then I have another 10 minutes, that should be fine. So if I have a slap bass pattern on the left, which sounds like this, and the guitar pattern on the right, then the whole performance together definitely sounds like this, not very surprising. And this is something that can definitely be realized with internet music performances if the physical distance is not too far, and once you have a solid path, a solid behavior that your jitter buffer can be reduced quite low, then it is possible. But in many cases, we do not have this situation. For example, if we are separated by the Atlantic Ocean. So if I played with somebody in the US, for example, again, we would have the master and this, then we have bass on the left, we have on the right the guitar again. But now it changes to something we call master and slave. And Chris, he took the terms leader and follower. So if we take a look at the slave, how that sounds. So latency is now way beyond 25. Let's say it's about 80 or 90 milliseconds. It sounds on the slave side like this. So perfectly fine, because the slave just sits on top of the time of the master. So the slave just plays to that and doesn't care how much it took for the signal to arrive. But what happens to the master sounds like this. Which is not surprising because it takes 80 milliseconds for the slave. The slave plays on that, and then it takes 80 milliseconds again for the signal to be transmitted back to the master. So this is the master-slave approach, which can be quite annoying. But this is what happens when you play rhythmical music with latencies beyond the threshold. Another situation happens here. Imagine a situation where latency is not way too high, but it is slightly beyond the playable threshold. So you couldn't keep up with the timing, but you can consciously place a rhythm section on one side and a soloist on the other side. And in that sense, it sounds like this on the slave. Oh, sorry, I'm interrupting here because it's clear. The slave plays on top. It's the same as we had before. So the slave doesn't perceive any latency. But on the master side, we still have the effect of the slave arriving too late. But the slave is just a little bit laid back and it doesn't really harm. So the slave doesn't really play laid back, but the latency makes him or her appear a little laid back. And it sounds like this. So now he's not really playing on the beat precisely, but it doesn't really harm. He could also have played consciously slightly behind the beat. And this is possible because we have the rhythm section on one side and the soloist is coming in. So this is how you can approach a situation with too high latencies by consciously dividing rhythm and solo section. And this is also not a clear number we can place here. Some musicians like it better, others not. It's also possible to delay your own feedback of a signal once you have a latency which is too high. So the signal is sent out immediately, but you hear it slightly delayed. And this is a way how to compensate latencies beyond the playable threshold. And you either delay one end with a round trip delay, or you delay both sides with a one-way delay, or you could also play with it and move the latency from one player to another. So delaying your own feedback is a way how to compensate latencies beyond the playable threshold. So this is what I call the delayed feedback approach. And then there is the latency accepting approach. It basically means it doesn't matter so much how high the latency is. You just play music which doesn't really have a metronome. It is music which doesn't depend on something that really has to be on the beat. And contemporary music, so something that is more open, more free, and more lives from phrases throwing to each other rather than having some conventional music which is beat oriented, then you can play with almost any latency if it remains below, let's say, 500 milliseconds. It could be performable also with conventional telecommunication systems, for example, this. These were two players, one in Stanford, one at Sark in Northern Ireland. And this is something which can definitely be played with latencies, which in that case were about, I think, 150 milliseconds, more or less. So I want to summarize. Distributed music is a complex domain with various artistic and technological issues to overcome. There is no ultimate way to go. The applied technology and its configuration depends on the individual requirements. Therefore, an objective comparison is difficult because of the subjective character of that domain and the people themselves. Nevertheless, network music performance projects each follow more or less the same principle. Basically, grab as quick as possible an audio buffer and send it via UDP in a peer-to-peer fashion. Then jitter buffer upon reception as little as possible, and then directly feed it to the playback process. And this way you are basically ignoring most of the conventional telecommunication standards. So the choice of technology is often then basically driven by personal taste and minor details. And then, and this is the last thing I'm going to talk about, mixing servers are becoming more popular nowadays, especially in context with larger choirs, because these the most suffer under the current situation, or orchestras with many people. But if you have more than 8 players, a server can work out. They typically introduce more latency, but they allow a higher member count and often exhibit better network stability. See on the left, who doesn't know about what that is, peer-to-peer, a meshed network means that anybody is connected to anybody. So everybody to everybody. And if you are connected with 5 players, you have 4 outgoing streams and 4 incoming streams. But not any system can handle more than 6 or 7 streams with very low latency. So you can use a server instead, where you send the data to, and everybody does that. And the server mixes that together and sends the mixed stream back. And that way, each connected client only has 1 outgoing and 1 incoming stream. Okay, so I think, I managed to cover all these details within the planned 25 minutes. The next part would be about the essentials of soundcheck, but this is part of my breakout session. Thanks for your attention and looking forward to see you in the next session.
Bravo.
So great.
I believe now it's going to be Chris and Aaron, correct?
Okay. So it's a pleasure to see everybody, at least, in 2 dimensions and many, many tiles like Hollywood squares, someday, some other way, I hope. I'm joined by Aaron, who is probably very early in the morning in Melbourne, and really grateful for everybody taking part. Alex, that was a splendid setting of the stage, and we we get a good impression from what you've just presented of what the issues are and the technological solutions. Aaron, I just want to check that you're there. Why don't you say howdy?
Morning, everyone. Well, I say morning, it's morning for me. Yeah, the sun is only just coming up here in Melbourne at the moment, so I'm still a bit out of it, but hopefully I'll be able to get through it. But thanks for having me here.
Okay, I'll cover for you while you get your infusion.
Thanks.
Okay. Yeah. A history of the work at Stanford. It really dates back more than 20 years now. It's surprising, that we've been working in this domain for so long. And some of my students, I think, were born after Jack Trip. I'm starting to get a little worried about that. The inception of it was actually a really wonderful moment. It was kind of like a wake-up call from, literally so. Elizabeth Cohen, who was the president of the Audio Engineering Society back around the turn of the century, way back then, asked me if I could demo something that used the internet and audio for a bunch of internet engineers and some audio engineers who were meeting in San Francisco. And I scratched my head and said, "What are you talking about?" Had no idea. But that led to some thoughts, and thoughts about latency, which in my world of experimental music and computer music and creating synthesis algorithms and all sorts of things, I thought, hey, maybe I'll turn the internet into a synthesizer. Anyway, that needed to have a method to stream audio uncompressed over the internet, exactly with the ingredients that Alex just showed. And we learned a lot over those years. Now fast forward to where we're learning a heck of a lot more in all sorts of ways about many more aspects of life than just network audio. But I kind of put a, I'm gonna put a pin in this period that began February, March last year, so nearly a year ago. and kind of talk about just quickly the world prior to COVID and then what we're learning now. In the kind of immediately preceding winter, so that's November 2019, we were starting to experiment with Jack Trip for things that we were already doing, but started perfecting it for concerts and so on. The Sarah Weaver's NowNet Arts Conference, it was having its second edition, and we had a lab ensemble going with musicians in Europe and the USA. The server mode, which Alex just described in Jack Trip, is called the hub, or the hub mode. And in order to do that conference, we had added some features to how the hub mode sounds, basically, like turning it into a room with people panned to interesting locations that sound like different parts of a room, the rhythm section on one side and the leads on the other side of the room, and some reverb and all of that. And it was really about creating a soundstage that everybody could dial into. And we had a micro version of that lived within the studio where I was working in Berlin, which used Raspberry Pi computers, and more on Raspberry Pis as we go through this. But another very kind of fortuitous and somewhat coincidental aspect there, that the Raspberry Pis, these very affordable small computers, can do this type of network music computation very handily, and the price point is low. I mean, $50 for a Raspberry Pi in the USA at this point that can run Jack Trip. And this experimental ensemble had 10 Raspberry Pis, all connected to a hub server part of a concert setup that we did in a venue called Silent Green, literally February 5th, a year ago. And now, from COVID, everything changed. I was back in the USA and started trying to work with our ensembles, particularly at Stanford, that were really high and dry at that point. I mean, we had no idea how the music department at Stanford would continue with this performance operation. And everybody was at home, everybody split immediately. And so we started to use hub servers and connecting them from home. And this was new. This was a real experiment that we all learned together in order to create some solutions for going forward with the ensembles. Very quickly, we learned that home networks were surprisingly up to the job. Prior, we'd been using university connected networks and getting, very good quality from that. All of a sudden, a place where I'm living right now, 6 years ago when I moved here, I couldn't make that work. And today I can do 6 channels from my home and very, very clean. And I didn't change anything. This is a network that just got better by itself. And so hopefully everybody's experiencing this kind of increase. Many musicians took part in our IETF, which I think Lori and David, was great having them join this. This is back in April, at the start of trying to figure out what we were doing. We called together musicians and some engineers who would be perhaps helping the musicians, get online together. That was the initial intent. But I'll tell you, after all of this got in gear, there was no difference. The musicians were figuring this out. The engineers were playing the music. There was no separation of roles, and it continues that way today. So this was the sort of manifesto for IETF at the beginning, and Bonnie Kwong is leading weekly meetings of IETF, and as we moved kind of the world of network music performance from this kind of pan-global, country to country thing that we were doing earlier to this necessity of the pandemic, that was the driver. And so many people have jumped in with contributions and new versions. That's what's such an amazing kind of feeling right now. And let me just say, I heard someone mention at the outset that, you know, the big takeaway might even be today to know who to contact. And I'll say that, you know, in this growth of interest, there are wonderful people to turn to for, you know, kind of hand on this. So it's both individuals, but it's also organizations that are offering solutions, some of which you're going to see today. Cynthia Payne has joined us. Cynthia is wonderfully generous with helping people get going. And I don't think I'm doing anything unusual for her by saying to 70 people, hey, feel free to contact Cynthia, because she's just engaged and has been helping. And we have other people who are consulting too, who can join. And there are now very plug and play solutions that don't require computer installation or anything like that. You just buy a device, a Raspberry Pi, connect it to a hub server, and off you go. So this is kind of our current thing. I've got 20 servers running at Karma in our building that has almost no people in it, but a lot of lonely computers. I've commandeered them for the Stanford Music Department's ensembles. There are, besides these always on physical servers like that, there's the ability to build your server in the cloud or order them up on demand. Two concerns where you can rent cloud servers, musicians together apart, and then the Virtual Studio web app. If you go to Jack Trip Foundation, you'll see Virtual Studio. And Virtual Studio is a way to, you know, do a kind of plug and play setup, get an account, get a server going, and have all your musicians on Virtual Studio Raspberry Pis. Let's see, this is actually a very blurry interface for the Virtual Studio servers. There's just a selection of them. You pick the one you want, you dial it up, and you give it a flavor that you want. At the top of my slide, I'm saying sphere of interoperability. It's very important in the Jack Trip world right now, at least to me, that anything that uses the Jack Trip software, which is really just that. It's an open source software community, typically in the past run by command line operation, but now growing interfaces like we'll see with errands. It's really important that all of these different flavors of Jack Trip interoperate. And so everything I'm showing is tested that you can sort of plug a Raspberry Pi into a Windows machine running Jack Trip. You know, I mean, plug means connect through the internet, not a physical plug. And the list is kind of growing. This will be what we see in the breakout room. It'll be a graphical user interface, very blurry here, but it just says select a server, connect to it, and your audio connects, and we'll show how that works. Here's one example of a Raspberry Pi interface. This would run on your mobile device. So there's a Raspberry Pi, you talk to it with your phone, and you say, start session, and off you go. Here's another flavor, which is a DJ system based on Raspberry Pis for synchronous DJing across Canada. That's where this project is located. Then there are other systems which are using Jack Trip as a protocol, and we aren't fully tested out yet. One I'm really excited about that will be compatible probably is Jack Trip running in the browser. So this is with no hardware, no do-it-yourself software. It's just go to a website, and you even have video. So it's this kind of thing where you typically have with Zoom. You know, you have several clients all seen together in the browser window, and in this case, not trading audio the way Zoom does, but trading it with Jack Trip style uncompressed audio in stereo. I'm going to skip this slide deck, and talk is actually also for Monday, and it has a little more depth than I want to go into right now. So I'm going to skip some slides and just say that what's really such a gas right now is the number of improvements that are coming in from contributors. I have a list of them here, and they're just things that I think we might have identified over time without COVID, but today we are roaring ahead to make all sorts of improvements that we, have identified newly or had in the queue, and some more kinds of stuff there. Here's maybe this is almost my last slide, and then over to Aaron. This is a microscopic look at an audio connection from my house to a server at Stanford and back. And what I'm doing is just checking the perceived latency in milliseconds. So you can see it's sort of around that number that Alex was talking about. So from my microphone to the server bouncing back, this so-called loop back to my headphones. And you can see that it's changing over 25 milliseconds, but it's pretty well bounded. And then you can see a few dots, and those are lost packets, which are little clicks. And this is at 32 audio samples per packet. And that's a pretty clean connection. You can play really good music over that. And so we have ways of kind of looking in, compensating for it. And in the future, we'll have better and better hub server rooms that give you a full binaural experience, or fancy full kinds of things like rooms that are harps, Aeolian harps that you sing into, and so on. So I'll just, I'll sort of leave off with a demo reel that you can go to someday if I pull this off correctly and stick it in chat. Yeah, okay, so not today or not during the session, but there's a set of demos that you can go to at that location that's in the chat window. Also, this slide deck for future reference is on my website. Great, and Aaron, over to you, man. And I hope gave you enough of a break. Okay.
That did. I'm slightly more awake now. So I guess just to add on to what Chris has said, my involvement with actually coding for Jacktrip came about once again because of the pandemic, start of last year. I'd used it quite a bit previously with with various sort of telematic music performances. I played myself in a new music ensemble called the Decibel New Music Ensemble, and we've had various collaborations. Actually, I think one of the link-ups was between Stanford and the Hochschule for Music and Theatre in Hamburg a couple of years back. So I'd used it for various projects, and being fairly technically minded myself, I didn't really have a problem with the command line, was happy to use it. But whenever I got excited about it and talked to other users, other musicians, I should say, you would start describing the process of setting it up, and they'd hear the word command line, and you'd kind of see their eyes glaze over. So I eventually got into writing the graphical user interface for it, which has become, as my version of the program, QJacktrip. It's basically just Jacktrip itself with this optional graphical user interface added over the top. Yeah, when I was first getting involved in the project, actually, it was really just a bug fix. So in the hub server mode, initially there was a problem where you'd have a buzz that would propagate through the system whenever someone disconnected, because the buffers weren't being zeroed, and it wasn't honoring a specific sort of user flag on the command line to zero the buffers when no packets were received. And so I thought that would hopefully probably be an easy fix. Looked through the code, got to know the code a bit, and sure enough was able to fix that. And then, having had that sort of vague familiarity with what was going on, thought, well, what else can I add? So turned my hand to adding IPv6 support to the program. So for anyone who is lucky enough to have an IPv6 connection, it makes it really it makes it much easier to be able to connect to other people online. One of the problems with a lot of the apps that we see especially on the peer-to-peer front is that because of the lack of IPv4 addresses, because we're basically running out of them, most people only have a single public IP address which exists on the router of their network. Every other machine that they connect to that network then is behind that router and shares that public IP address. And there's a lot of, I guess, trickery that sort of goes along through network address translation to make sure that packets get from one end of a connection to another. And that's fine when you're talking to a public server that has a public IP address and is run by I said, a big organization that has a lot of public IP addresses at their disposal, it becomes more problematic when you have another person stuck also behind a router, which is what we're doing for the most part when we're playing music online with people. They're hopefully, I mean, as I said, once IPv6 support is more common, that'll hopefully become easier. We're looking into potentially other ways of getting through routers a bit more sort of transparently to the end user. But at the moment, with a lot of these solutions, there's still some basic knowledge required for routing. I won't get too much into the actual app itself because of I'll save that for the breakout session. But I'm just going to quickly share my screen. I can work out desktop 3. Excellent. So this is that's the code there. This is the QJacktrip window. See, I'm running Jack on Linux, so so Jack is the low latency audio server that runs behind the scenes and sort of can route everything through that I need it. I've got a slightly complicated setup with all my various devices going on here, but basically that's the low latency audio backend for Jack for Jacktrip. And when I create a server here, I'll just create a normal P2P peer-to-peer server. So as Chris was saying, there's peer-to-peer mode and there's hub mode. You just need to make sure that peer-to-peer client always connects to a peer-to-peer server, hub client to a hub server. But if I set up a server that I want someone to join, you can see there's not a lot that I have to do here. And I just hit start and you'll see it's appeared here. And there's the sends and receives. So I can, if I wanted to, I can't do that yet because I haven't actually, no one's actually connected. But once a client connects, I'd be able to just plug my microphone here into there and the person on the other end would hear it. The most useful thing here as well is it shows you your external IP address. So this would be the IP address on your router. If you're lucky enough to have an IPv6 address, it'll show that here. You both need to be using the same protocol. So if the other person doesn't have an IPv6 address, you're out of luck there. But I'll show you more about that in the breakout room session. But yeah, the graphical user interface just makes it a lot easier for people to use Jacktrip on a machine that's, I said there are other easy ways, such as the Raspberry Pi, which is sort of the self-contained system. But this way allows you to do it with, if you've got existing audio hardware and a decent computer, you don't need to invest in any additional hardware. And you can use it, as I said, without having to know about the command line. But I think that covers everything from me. And hopefully that hasn't taken us over time.
All
So
right,
now
Chris
we just-
and Aaron. Go ahead, Laura.
I'm sorry. So now we need to hear from Jesse.
Hello. I am Jesse Chappell. I'm a software developer from Virginia. And as all the other people have already said, they pretty much described the situation. So I kind of came in early in last June and kind of looked at the scene of the different software that was doing this kind of stuff. And I kind of saw a few holes that maybe I could fit into and fill some of the requirements that maybe they weren't doing that I saw. And so for some, I kind of apologized to Chris. I looked at Jacktrip and I ended up choosing not to contribute to that based on just some of the features I saw in another library called AOO, Audio over OSC, by Christoph Ressi. And I mean, the reasons I chose that were just, it was already in sort of a library form, so it was easier to take to use it kind of directly and integrate it into something that that I could use as a plugin more easily. And it had a few other sort of features that meant I didn't have to do them. So I kind of apologize for if I put my effort into the Sonobus and I didn't help Jacktrip. Sorry. Anyway, so yeah, what I did with Sonobus was, the goal was to come up with something that was a little bit more easy from like an end user perspective to set up, like the most common case in my mind, which is at first was just small groups, easily connecting to each other all together in a group, so everyone could hear everyone else. And then having the sound quality sort of be prioritized. The latency is a concern, so I wanted to make sure you could have the ability to see what the latency numbers were, what the statistics were, be able to change the jitter buffers easily, independently for each person. And so it was almost like when I first made it, it was for me to be able to see all of the moving pieces in one interface that was simple, but also to maybe support. I wanted to support a lot of platforms, including iOS, mainly just because it was easy to do it. I use this cross-platform sort of toolkit to build it all, and also to make like a plugin version. So if you're using a DAW, you could just load it in as a plugin and easily route the stuff from there. So if you had some effects or other sort of live processing things that you did in that kind of scenario, then you could easily use Sonobus and connect with someone else, or do remote recording sessions, stuff like that. But so the main difference with Sonobus is it is at this point simpler. It just does peer-to-peer right now. So like you mentioned, it's good for smaller than 8 people at a time, and so for large groups trying to work together, it doesn't have a server-based hub mode yet. I mean, I have some ideas and ways to possibly extend that later, but for now, it's just peer-to-peer, and but it does work on a lot of different platforms. And I actually made an Android version beta, but it's not quite ready for prime time yet. But the issues with the Android and the iOS is that all these, we actually maybe didn't mention it here, but it's very important for you to get the best results to be on wired Ethernet to your router. And so a lot of people don't have that set up for their mobile devices, although you can. You can actually hook up USB to them and use a USB Ethernet interface with your iPad or your iPhone and Android device too, even. But a lot of people don't have that set up, so using Wi-Fi works, but the jitter is a lot more, so you end up using bigger jitter buffers, and you get a lot more latency based on that. So that's a question that might come up. I don't know if we addressed it here yet, but yeah, the main reason to use the wired Ethernet is so that the packets are delivered in a much more stable way, and that makes it so you can have the lowest latency. So I know we don't have much time. I don't have that much more to add. I don't have any slides or a presentation here. I figured I'd be at the end, and there wouldn't be much left anyway. So I could show the interface here, but I'll just probably easier to do that in the breakout room. And if anyone has any questions about what they might want to hear from me.
I just had a quick question. I didn't understand what you said about using the Wi-Fi and increasing latency. Using the Wi-Fi versus what?
Versus an Ethernet, like a wired Ethernet cable, to your setup.
Isn't that generally true for all the programs?
That is true for all the programs, definitely. And I just, it's a very important thing. And I know we didn't actually mention that. I don't think we mentioned that too quite enough, but it's super important for you guys to do that. And a lot of people in the last year probably have started to do that, especially if you're doing music stuff. But it's an important thing to not forget.
All right. Thank you so much, Jesse, Alex, Aaron, Chris. Wonderful. And I think we're ready to go into the breakout rooms. So they are already set up. Lori, the people just have to choose them, right? You talk here.
So I have breakout rooms already ready to go. There are breakout rooms for all 3 platforms. So all you have to do is pop yourself into one of those rooms. And I see some people already doing that. Do you all know where to find the breakout rooms?
You see our questions here about, for a little bit of advice on bottom line of what factors enter into our choosing?
Yeah. Did you want to say something, Alex, about SoundJack? Because you talked about the basics, but I don't know if you gave any details about.
I was thinking to cover the soundtrack details within the breakout session. So I think that makes most sense, right?
It does, except these people, I think, they don't know which breakout session to go to.
Ah,
That's the problem.
So
Maybe you could distinguish yours from what we've just heard about the other two.
Yeah.
To help us decide which one to go to.
Will also help us figure out how to get there.
yes, some people are asking questions I see about how to get into the rooms.
Rooms aren't showing up anymore. The box was there for a while and then it disappeared.
Oh, well, you know what I'm going to do is apologies to the people that are already in rooms. I'm going to close them and reopen them. And then you should see you should see an invitation pop up to join one of the rooms.
Okay.
So just give it a second because they're going to close in about 50 seconds. People should pop back in here confused and then I'll explain it.
And are you going to be able to leave one room and join another if you wanted to see if one was working for you, and if it's not working, you could join another?
I believe that you can. You can leave the room once you're in a breakout room, where you know on the bottom right hand part of your screen.
Right.
It says leave room. You can leave the room, go back to the main room, and then I believe you can enter a different room.
I had to leave the meeting in our workshop before. I had to leave the meeting entirely.
Right.
So I couldn't just leave the room. So I guess not. Okay.
Yeah.
And do remember that we are recording all three rooms. That's part of what the helpers are going to do, so that you will be able to get the other stuff too.
Yeah. So so again, my apologies for those of you who are already in rooms. The breakout rooms had disappeared for some people, so I wanted to close them and reopen them, start again.
That explains it.
Yes. So I'm sorry.
So they're reopened. They're reopened now.
They are. As of right now, I'm reopening them.
Okay.
Laurie?
Yes.
Just to responding to what I think people were asking about, like one sentence, like what would you be going to in all three? I think I have a clear idea of two of them. And then maybe, like I think the Sonobus is basically peer-to-peer, maximum of 8, multiple platform. I think the Jack Trip is kind of accommodates larger groups, has like virtual studios, and I would leave it to the professor to summarize like the SoundJack. I learned a lot about like the overview, but I wasn't exactly sure the approach of this one.
Okay, if you want me to cover some basics, I just go to the very first slide of my breakout session, then you get the best idea. I think that okay for you?
Go ahead.
Makes sense. Okay, good. So SoundJack is basically inspired by Jack Trip in 2002 by the very first version of that. It was called Stream DBD. And the first public version was available in 2006. And in 2015, we had the separation of the core and the browser GUI. It supports peer-to-peer and server at the same time. It also supports social media structures. So it's a little bit like Facebook, but I really don't want to be like Facebook, but I'm really trying to implement those social media functionality as well. We have many people using multi-channel 3D audio, so we can basically transmit 16 channels, for example. We also have a very low latency video component, which is just slightly behind the audio, but it's still beta. I will give some introduction into that. And we also have what Chris described is similar to that, something we call Fast Music Box. It is a hardware-based device. It's a hardware device based on Raspberry Pi, which is becoming quite popular in terms of usability these days. And these are the essentials I would like to cover within the breakout session. Is that okay? Is that understandable?
Somewhat.
There's no way to really tell without just trying it. I mean, you can't do it.
Yeah,
in
that's
2
what I
minutes.
was just about to say. So it's up to you. And if you don't want to join Soundcheck, you can contact me at any time later. So this is not really restricted to this session right now.
Just
Can I
to
ask a question? How many people can use SoundCheck at the same time?
With the server, it depends on the actual server you're booking, and it could be up to 100 possibly, which we haven't done. But we ended up like with 36 at the moment. Regarding peer-to-peer, you can still use 10 or 12, but then you have to increase buffers. I am safe at about 7 or 8, but I wouldn't recommend using more than that in a peer-to-peer session.
Okay, thanks.
So I am now seeing that there are 21 people in the Sonibus room, 2 people in the sound jack and 3 people in Jack Trip.
So I'm so,
And where did you want me in Jack Trip or somewhere else to tech? I need to know where to go.
Well, let's see. I have which one? Who said?
This is Hallie.
Right, right. So Hallie, I think we have. Who else? Yeah, we might. If you don't mind, unless you want to. Actually, if you really want to go someplace else, I can go to Jack Trip and.
Wherever you need me, just let me know.
Okay.
So sorry, Lori, do I just go to leave meeting and then I'll see the?
No, don't go to leave meeting because then you'll.
I didn't think so.
But you see where the bottom of your screen, where it's all the little icons at the bottom of your screen.
Right.
There's one that says breakout rooms.
Yeah, I don't see that myself. So
You don't see
I don't see it either.
You should go to more, hit more.
Oh, yeah. Okay, got it. Thank you. More on the audio.
Where's more?
Where's more? Speaker.
On the bottom of your screen, on the right, there's 3 dots that say
right,
more.
but it's all it does for me is it shows who's in the breakout rooms, but it doesn't.
and I don't see that.
One.
Okay, I actually can assign people.
Yeah,
So
put me in
let's
Sonibus
see.
for now if you can.
Okay, look,
Lori, that's Karen.
I'm looking for you, Karen.
I know it might be alphabetical under K.
Yeah, I know. It makes sense, but it actually it's not. But I'm
weird. Yeah.
I'm putting you in Sonibus, Karen.
Yes, please. Thank
Okay.
you.
Okay, would you put me into Jack Trip? Eugenia?
Eugenia? Yes, hold
Yes.
on.
Oh, I see them. Oh, no.
Eugenia. I see you, Eugenia. And I'm assigning you to Jack Trip. Okay.
Lori, this is Erland. Do you still want me to go and help in sound jack? How many are?
Yes. That would be great, Erland.
Can I move you there or can I move myself there?
Okay.
Hi, Lori. Hi, Lori.
Yes.
Yeah, this is Deirdre.
Hi, Deirdre.
Yeah, I asked you to get me into Sonibus. Can you help me?
Absolutely.
Thank you.
Sonibus it is.
Rex Loker also into Sonibus, please.
I think I just figured out. I think I just figured out how you get into the rooms yourself, which is, for me at least, to click on the number to the right of the name of the room. I somehow didn't pick that up before.
Okay.
Yeah, but some of us are not even seeing the number to the right of the room.
Okay,
So,
so who
can
else?
you just put me
There
in?
should be a join button that you can join.
Connie, where do you want to go?
Could you just assign us, and then if we don't want it, we can come out?
No.
Let's do it this way. Connie, where do you want to go?
I just popped in. I'm just watching, but I think on Jack Trip.
Okay, Jack Trip.
One is this one, Lori.
Jack Trip. Okay.
Hot glue in the gun.
I can pick my own. I'm good. Thank you.
Okay, Raymond. Raymond.
David, I want to tell you something.
Yeah, put me in Sonibus, please.
But I want to tell you something. Sonibus has so many people, he's worried how he's going to manage to do it with everybody. So he almost needs 2 rooms there for it to be successful.
We can't
I just
do
came
that.
in here to tell you that.
This is Brent. I want.
Do you want to put me in Sonibus and I'll co-tech? This is Hallie.
Sure.
Done. Did it. Okay, Brent, where do you want to go?
Sonibus, please, David.
Sonibus. Airly. Jeff Siegel.
Sonibus.
Carl.
Jack Trip.
Catherine? Catherine Fathers? Tony?
I can choose myself, but I want to ask Lori, do you need me to volunteer in I thought I was volunteering in Jack Trip, but if you
Okay, yes. Why don't you go to Jack Trip then?
okay,
Yeah.
I'll
Anybody else need help? Okay.
What's the one that's not Jack Trip and the
Sound Jack or Sonobus?
Sound Jack? Okay.
Yeah.
I want to try Jack Trip if it's okay, because
Sure, you wanna
to
go to-
try something new.
Okay, now I don't see you anymore, Karen.
I'm on your screen.
I know.
Yeah,
I mean,
but you're in the room.
Remember before I had to leave the meeting entirely when this happened in my
Oh,
workshop,
okay, I
right?
see. I'm gonna move you to
Okay.
Jack Trip. Okay.
Thanks.
Yep, gotcha.
I'm going to Sound Jack.
Okay, and I'm gonna I'll go to
Wait,
Jack Trip. but-
how do I go to Jack?
So who else needs to be assigned? Anybody?
I'm waiting for Sound Jack.
Who is that? Early?
Early.
Okay, I'll put you in Sound Jack. Gotcha. So now we got Eric is still here. Eric, do you need an assignment?
Lori, can you hear me?
Yes, Erland.
Alex can't share his screen. It says the host has disabled the screen sharing.
I have all participants are able to
All platforms.
share. Yeah.
Share screen?
Yeah.
And that works in the breakout room?
It should be able to, but let me.
Why don't you go in there?
Yeah, I'll go in
Here
there.
I am again.
Hi, Karen.
Hi again. So I forgot the only software I didn't download was Jack Trip because it was going to take too much.
Which one do you want to go to?
Well, I've been in Sonobus, but he said there were too many people to do it.
Why don't you
so-
come to the Jack? The other one.
Sound Jack, I know that works with me. I'll try that again.
Okay. Lori, can I go back in or do you have to put me in?
Try going in, and if you can, I'll put you in.
Okay. And you might want to check to see about
Sound-
the sound
Yeah.
check in terms of
Yeah.
being able to
I'm gonna do
share
that
the
right now.
screen. Yeah.
Yeah, Sound Jack, I can't do anything myself. Sorry.
Yeah, I don't think I can do it either. David, can
No,
you?
we
put me
can't.
No, I can't either. That's weird. I can't even move myself.
in? Really?
Ah,
That's frustrating.
Yeah.
David, I couldn't record my workshop this morning because
yeah?
I wasn't the co-host. Because Josh.
I
didn't
am a
make me the
co-host, and I don't see how it
Yeah.
gets me into a room.
Is she coming back?
I don't know.
Oh no, we're stuck here. Hey, why don't you just teach us?
What do you want me to teach you?
I would love to see if Sonobus works now that I have an aggregate device, as my interface is an aggregate device.
Okay, let me start it.
He has like so many people, and then there's no way. He said
Right.
he doesn't think it's going to work. So,
All right.
and I have to start it in addition to this, right? And is this the one that doesn't use the browser?
Correct. Hold on, I'm going to have to...
Press connect button to start. I'm going to call us PMN.
You know,
No, I'm creating a group. I'm creating a group
Oh,
called
you
David.
are. I just did.
Okay, so
Okay,
PMN?
I'll disconnect. Well, I'm disconnecting now.
Okay, I'm creating a group called David
I'll
PMN.
connect. Okay, I'm going to look for you.
Okay, so now you got to
David.
find the group David PMN.
PMN. Is there a password or no?
Shouldn't be.
Oh, permission denied. Oh, geez. All right.
I don't think you could be on two Zooms
can you
at
invi-
once.
No, we're not talking about Zooms. We're talking
Can
about...
you
Something else.
can you invite me? I think you did before, right? Because that didn't work.
yeah, you invited me before to Sound Jack.
Oh, I just found it. Never mind. I just found it.
Okay.
What did
No,
you-
that's the one I created, I guess.
Well, I see a Sound Jack with 10 people in it, but I don't have anywhere to go to it.
Sound?
Sonobus.
No, but I was supposed to go to sound. Oh, join, okay. Yes.
Oh, now I'm being invited to Sonobus.
Yeah.
Okay.
Hello?
Hello?
Hey, is Laurie here?
No, she's not.
No. Can he be made a co-host while he's in a breakout room? Sorry, Soundjack. What is his name?
Oh, Alex.
Yeah, Alex. Can you make him a
Let
co-host
me
or
see if I can-
something?
Let me see if I can find him. Hold on.
Yeah,
I don't know if I can or if Laura can.
you should be able to.
No, why?
He's in that room, right?
I know. Because I don't, when I look at the participants, I don't see,
Yeah.
I don't see him. Lori has,
Would you mind? Oh, so it's because you are a co-host. You don't
I'm a
have that.
co-host, but
You're a co-host. So
that's a drag.
yeah, man. Well, this is
Yeah.
I mean, it's pretty fancy stuff that we're doing.
Yeah, what I can't even, to be honest, I can't figure out how to get me into that room because I don't, maybe because I'm a host, I don't show up.
That's odd. You should be able to.
I don't see
So when you go to
myself on the
breakout, what do you
list.
see?
I see everybody but me, and I don't see.
Okay. Do you mind sharing your screen? I might be able to walk you through it. Yeah.
Oh, sure.
Yeah.
I'm also in this sort of alone with a couple
Okay.
of people.
So, but the problem is Zoom won't share Zoom.
Right,
No,
but you're seeing,
I
but you
can't.
are seeing
No,
this.
no, I'm not seeing. I'm only seeing whoever's singing at the piano.
Oh, you're not seeing this
Like
thing
I
here.
zoomed out. Yeah, that's not going to work. Zoomed. You could take a screenshot.
Okay, there you go.
Right.
Of what? Of my breakout room?
Of your whole screen is enough,
Okay.
or just of your breakout room, whatever it is, and then share that. And then I could with the breakout room open, so I could see it. Because then.
Okay. So what? I have to email it to you, or?
No, just you could just share that, like open it on your screen and share that. Zoom just can't share itself.
Got you.
I'm not sure where I am. I'm with 3 or 4 other people.
What kind of device? You're in the main room. What kind of device are you using, Polly?
MacBook. Air?
On a MacBook, on an Air, right? So
Yeah.
when you hover over the screen, do you see on the bottom of your screen, do you see something that says breakout rooms? Right around where you would see mute or whatever?
Yes, I do. And I went there before, but I didn't know how to get into one. I see the list, but I don't know how to join one. Or I was in one, but it seems to have dwindled.
So is there a number next to, like, if you see the list?
17, 11.
Polly,
I mean, that's the number of people.
I see your name, Polly. What room do you want to go to?
Oh yeah, you can.
I don't care because I missed the introduction, so I'll have to watch the recording later. But I thought I'd try to.
I just put you in
doesn't
sound.
really
Jack.
matter. Oh, thank you. Thank you very.
So I think that the issue is, David, that the main room has to have somebody who's a host or a co-host stay in it, because I'm looking at it and I agree with you. There should be something, and I think that that's the issue.
Because Lori's not here,
Lori's not here, you can't leave. That's what I think. That's what I think. Because thank you for sharing that. You don't have to show your whole screen if you want, but
I actually just can go into SoundJack on my own, and then I'll see them.
Right.
SoundJack.
Yeah. Yeah.
What were you doing? What were you?
I was in SoundJack, but he wants to share his screen, and he has to be made a co-host because I think because she deals with students at school, she's got all of the settings more secure than are friendly for this kind of work.
Right.
That's my theory.
I think if I was in there, I might be able to do it. But let me try. You know what? I'm going to text her.
Yeah. There you go. Yeah.
Why didn't I think of that before?
Right.
Yeah.
Well, it's because we're in a. The brain has a hard time when it's learning to multitask.
Please excuse me. Could I kindly ask you a question?
David, while you text, what's your question?
Thank you. I appreciate it. All morning, I've been trying to download Sonobus. I just got out of the emergency breakout room. She doesn't know how to do Sonobus. I have an iPhone. I have an iPad, and in both cases, I touch download, but nothing downloads.
So you're touching. So you're on the App Store.
Well, right now, I'm at the sonobus.net page.
Okay.
And then it gives me three choices: Mac, Windows, iOS. So I've been touching Mac. I assume that's. So I touch download.
No, if you have the phone or the iPad, you want iOS.
Okay, thank you. That I believe I tried it, but okay. So now it says
because Mac is the computer.
Okay.
Yeah, she's got it.
Okay, I'm very grateful.
Sorry.
So now it says step 1, get test flight. Does that mean?
Oh, I don't think. See, I don't. I'm not sure if it's actually implemented on the phone yet. I remember seeing that.
Well, I'm actually on my iPad, but so what you're saying is I have to be on an actual laptop?
I'm going to go try it. I'm on my iPad. Let me see if it works.
I really appreciate it. Thank you.
So this is Sonobus. Do you know the website? Is it Sonobus?
Yes.
.net?
Yeah. Thank you.
Okay. Oh, of course. Hey, I'm Joel.
Oh, okay, thanks.
Yeah, sorry, I've got the band name on the thing.
Yeah, I know. I heard you last night. Great stuff.
Oh, thanks, man. Thanks. Okay, multiple devices, and then there we go. iOS on the App Store, public beta, and then right under where it says Step 1, get test flight.
Yep.
It says View in App Store.
Yep.
Click View in App Store.
Okay. I guess the confusion is that it's called test flight, but it's Sonobus.
Exactly, but it's Sonobus. But exactly,
Okay.
Except right. It makes it easy to test beta version. So you're going to have to it's a little bit complex because it's in beta, and it's not like super advanced techie, but it's like intermediate techie. Does that make sense? Does that make sense?
It does.
Right? Like it's
on the computer. Sonobus is very easy.
On the computer, I bet it's very easy. And in a month or so, when we're done the beta or whenever it is done, then it'll be a lot easier. You'll just be able to, on that same web page, go to the iOS, and then you'll go get it and download it, and it'll be an app on your device. But for right now, while it's in beta, to really try it, you're going to have to use a desktop.
I got it, because right now it says no apps available to test. So
So you'd have to get test flight. Open test flight,
I did,
and then go get it.
I did.
Yeah. That's exactly it. Yeah. Join the beta and then start testing. So if you have did you already download test flight?
I did.
Okay, so go back to the web page after step 1 and go to step 2, join the beta.
Okay, good luck to me. Here I go. Okay.
No, I think you can do it. I'll stay on the line. It's fine.
Thank you. I've been trying this for hours. Okay.
It's all right. It's what to do.
Page, and now I touch iOS again?
No. Well, yeah, iOS again. Yeah.
Okay.
And then go to,
and now it's okay. So now it says Sonobus. Now I say accept. Now it says test flight on top and Sonobus under it. So now it's allowing me to try Sonobus.
Good. There you go.
So I say accept, I say install, and I say thank you very, very much.
Excellent. Oh, good.
Have a beautiful. Thank you.
I should have been doing that myself. I should have been trying that myself.
It's always. I've learned. So I do my day gig. I teach. I facilitate learning sessions for a literacy software company with teachers, right? So I spend all day doing.
Walk me through that then. Walk me
Sure. Like for iOS or for
iOS.
For iOS, you're going to need to go to the website.
So in other words, open Safari, right?
Yeah, open Safari and go to sonobus.org. And then that's where it was, right? Yeah.
That's what I believe so.
Okay. Right? And then
no, it says could not be found.
No, I think
sonobus.net. I'm sorry, I lied.
Oh, .net, right.
Yep, I lied. Right. No, I'm looking now. It's .net. And then you scroll down the page about a while and it gets to download. Choose your platform. Got that?
Right, choose your platform, right?
Right, and then your choice is Mac, Windows, iOS or Source. Okay. So iOS
on the App Store, right? Public beta.
Right. And then first you're going to need.
So open and test flight.
Well, that sounds like you already. Well, are you writing down or are you looking at a screen right now?
I'm looking at a screen.
Oh yeah, if it says open and test flight, that means you already have the app. Yep. It's that you have to go back and do it again. I think that hung up people.
Oh wait, now okay. Then it says no, but then okay, now it says accept, install.
Yeah. Mm-hmm. There you go.
Okay.
Yeah. That seems to be work. I mean, I haven't tried it yet, but I might as well do it, right? Yeah, I might as well do it. This isn't going to kill my iPad.
Yeah. I mean,
right? I don't know why. See, I'm doing the same thing. I'm not even doing it. I'm talking to you.
Right, and I was listening to you tell her, and I wasn't doing it. Sonobus is really very interesting. I mean,
it's very interesting, this whole thing. Yeah. I'm really glad that my wife is able to attend the Songs of Spirituality right now because at least half of the band is there.
What's her name?
Carrie.
Carrie, K-A-R-I?
C-A-R-R-I-E.
That's what I said.
Yes. Exactly.
Yeah.
Okay, what's your name? Hold on a second. I'm not because I'm David Joel. Yeah, David.
Yeah. Pleased to meet you, my friend.
Likewise, my man.
David, I got into the Sonobus room. I got pulled in there when I tried to join you on Sonobus.
Yeah.
It asked me to join the David PMN. I clicked join and I went in there and they were already in the middle and nobody would tell me where they were. So I was like, oh, I guess I'm coming back here. I couldn't figure out because their screen didn't look like mine. And anyway, oh, well.
I'm in David PMN now on my phone.
Oh, you are? Oh, so you got in. Okay, so I'm going to, and is it a capital D?
No.
Lowercase David and capital?
David hyphen PMN.
Oh, hyphen. That's, so I shouldn't try to, I would think I was trying to search for it.
Yeah.
And it only gives me, I'll try it again.
Joel, you want to try and join us?
Sure. Where am I going? Hold on a second. I just got, Zone. Hi. Where am I going? Hi. Where are we going?
To in Sonobus, you should be joining a group called David-PMN, all lowercase.
So is this like a sub breakout room?
Well, apparently we're just doing it because we can't do anything else. But it's all.
We're just doing it
right now. I see when I look at join breakout room, I see Jack Trip, Sound Jack, Sonobus, Emergency
No,
Help.
I'm
That's
just
my
doing
option.
this on the side because I can't
Oh.
get anywhere else.
We're
so
just doing Sonobus.
We're just doing Sonobus.
Okay.
So feel free to join us.
So just go into Sonobus and give it a try.
Oh yeah,
Oh,
that's
I've got
what
an
we're doing.
echo.
We're playing.
Yeah.
We're playing.
And I'm going to mute here.
Okay, connect button. Sorry, what is the group name?
David-PMN, all lowercase.
Thank you.
I'm just unmuting because I realized you couldn't hear me through Sonobus, and I'm showing that I have signal, but I don't know why you can't hear me.
Right. I'm not hearing you through Sonobus. Why?
Why? I'm going to try some things.
Oh, wait. I think I know why. I think I do. Let's see. No, that's not why. I take it back.
What's going on over here?
I've got aggregate
We
device.
couldn't go anywhere because I don't see my, so we're just trying.
You're
Sonobus.
there.
Like I didn't show up on the screen to get assigned.
Really? I see you there. I can assign you.
Forget it. We're doing this now. We're trying on our iPhone Sonobus, me and Karen and Joel and Eric.
All right.
Figure out why. So I made a group, David-PMN in Sonobus.
Cool.
Join us, Lori.
I will.
But I don't hear people on my phone. What's wrong there?
I hear you really well, though.
But
I don't know if I'm hearing
Karen.
I hear you, but am I hearing
Yeah,
you in
hear
Zoom?
me on Zoom.
Okay.
No, I hear you.
You're
I hear you on Sonobus.
You're muted on Zoom. You're muted on Zoom.
But I'm not hearing you on Sonobus. So what's wrong there?
I'm hearing you on Sonobus.
You are. I'm not hearing you on Sonobus. I'm hearing you through Zoom.
Right, I unmuted so you could hear me.
I hear you on Zoom.
Let me see something. Let me look at my connections.
All right.
Audio.
I'm gonna leave. I'll be right back.
What's the name of your group, David?
David-PMN.
Any capitals or just?
Okay, I see that. That looks good.
I hear you.
Oh, let's see. Wait, here we go. I think I got it.
I hear you.
And I disconnected. I hear you on Zoom again. Do you want to mute on Zoom? Okay. Well, I'm in Zoom. I'm in. Whew.
I hear a lot of feedback. Hello?
I hear Joel.
I hear you.
I don't. Can you say whose line just so we know?
Hello? Hi.
Does anybody hear me?
Looking for free.
Does anyone hear me at all? Why doesn't anyone hear me? Why? Huh. Latency. Oh. So I see. Oh.
David, we can't hear you.
Lori, do you hear me?
Not
Not through
I hear you.
Sonobus. I know it's not working.
Hold on.
But can you move?
Hold on
Yeah.
a second. I have to change earphones to be able to hear you. Hold on.
Oh God.
Okay.
I'm just wondering if you could put me in sound jack.
Well, I'm
And
closing
also,
I'm closing
closing
everything up
everybody
now. No, everybody's coming
Oh,
back.
okay.
Sorry.
Oh, okay. That's why people are short. That's okay.
Well,
Yeah.
that wasn't enough time.
I know it wasn't.
It's okay.
We're
Did everyone? Is everyone gone or they're coming back?
No, everybody's coming. I wanted to bring everybody back.
Good. Yes,
'Cause
definitely.
I want to first of all, make sure that, you know, everything got recorded
Yeah,
and
I
who
gave
recorded them.
Lisa and Joanne my email, and we're gonna continue because they were like starting from scratch.
Great. Well,
I don't have your
good.
email, Cynthia.
Okay, Cynthia with an S, Synthia.